Welcome to the Getting Started video for QYSEA's QYBT Bathymetric Tool. Open the outer carton and remove the product and accessories in order. Note: ensure the ROV is powered off before installation. Install the QDVL sonar module. Turn the ROV over so the bottom faces up. Remove the protective cap from the bottom Q interface. Hook the front locking tabs of the bracket into the ROV's drainage slots. Left tab to the leftmost slot, right tab to the rightmost slot. Pull the bracket rearward. Align the bracket knob with the recessed groove on the ROV's bottom, then turn the knob to lock. Align the key on the male connector with the keyway of the Q interface and insert. Push firmly until fully seated, then tighten the waterproof nut. The QDVL sonar module installation is complete. Install the GNSS locator. Take the articulating arm and loosen the black knurled nut. Mount one end of the arm to the locator, then retighten the black knurled nut to secure the arm to the locator. Take the GNSS locator and the cable. Connect the male end of the cable to the bottom port of the locator. To avoid pin damage, align the key on the male plug with the keyway on the female socket before insertion. Press the plug firmly until fully seated, then tighten the waterproof nut. Take out the top quick-release mount and flip the mounting plate over. Attach the other end of the joint arm to the center slot of the quick-release mount. Use the black fastener nut to secure it. Remove the waterproof cap from the ROV's top Q port. Align it with the dual slots on top of the ROV and place it down. Turn the front and back knobs to lock it in place. Align the key on the cable plug with the Q interface keyway and insert. Press the male plug firmly until fully seated, then tighten the waterproof nut. The GNSS locator installation is complete. Connect the tether spool and controller. Power on the controller and ROV. Open the FIFISH app and tap the toolbox icon to enter the UN's navigation system interface. Open the outer carton and remove the product and accessories in order. Note: ensure the ROV is powered off before installation. Install the QDVL sonar module. Take the QDVL module, turn the ROV bottom side up, and use an M4 hex driver to remove the 4 M4 screws. Remove the original bottom plate, install the QDVL module, and tidy the bottom cables to avoid pinching. Align the QDVL module with the screw holes. Then reinstall the removed screws and tighten. Remove the protective cap from the rear Q interface. Either Q interface may be used. Align the key on the male cable plug with the Q interface keyway and insert. Press firmly until fully seated, then tighten the waterproof nut. The QDVL module installation is complete. Install the GNSS locator. Take the articulating arm and unscrew the two black knurled nuts. Mount one end of the arm to the locator, then retighten the black knurled nuts to secure the arm to the locator. Take the GNSS locator and the cable. To avoid pin damage, align the key on the male plug with the keyway on the female socket before insertion. Press the plug firmly until fully seated, then tighten the waterproof nut. Mount the other end of the articulating arm to the mounting bracket and tighten the bracket to secure the arm to the bracket. Using an M3 hex driver, remove the 3 M3 mounting screws from the rear top mounting area of the ROV. Orient the thicker end of the mounting bracket toward the PLC port. Align it with the holes, then reinstall and tighten the removed screws. Turn the articulating arm knob to adjust tension so the locator stays vertical to the vehicle top. Align the key on the male cable plug with the Q interface keyway and insert. Press firmly until fully seated, then tighten the waterproof nut. The GNSS locator installation is complete. Connect the tether spool and controller. Power on the controller and ROV. Open the FIFISH app and tap the toolbox icon to enter the UN's navigation system interface. Offline map download. If the satellite or network signal is weak at the worksite, please download the offline map in advance to avoid any impact on use. With your mobile device online, open the FIFISH app and tap Help, bottom right on the home screen. To enter the Help page, select QPS Offline Map Download. On the Offline Map selection screen, tap Map to open the map options. After selecting a map, it will load online. Tap the search icon lower left. Enter the latitude or longitude near the work area and tap OK. The map view jumps to that location. Wait for the tiles to finish loading, then tap Start Select Area. Set a start corner and an end corner to automatically generate a rectangular area around the job site. Tap Download. Confirm the number of map tiles in the prompt and start downloading the offline map. Do not close the app or let the screen sleep until the download completes. Position Initialization. Use Position Initialization to automatically calibrate the ROV's initial position via the GNSS locator, providing a high-accuracy starting reference and improving navigation accuracy later in GNSS-denied environments. Connect and power on the ROV. Open the FIFISH app and tap the toolbox icon to enter the UINS interface. The GNSS locator completes initialization automatically, and the screen displays DVLDR Init Success. Interfaces may vary by mobile OS, iOS. Switch maps according to your preferences. The video uses Mapbox Map as an example. Other maps follow the same workflow and yield the same results. Android. Toggle the Offline Map button to enter offline mode. Then switch maps and select a previously downloaded offline map. One-Touch Return. Use One-Touch Return in the app to quickly stop the ROV's cruise and automatically navigate back to the start point. Before use, set the return point. Tap the return point icon, choose a suitable location on the map, and set the return depth to 0.2 meters. During operation, when the ROV is working in the water, bring it up to the surface while keeping all propellers submerged. Tap the One-Touch Return icon. Confirm Yes on the prompt, and the ROV will automatically navigate to the return point. If the ROV is currently in autonomous cruising, tap Stop first, then execute One-Touch Return. Smart Path Planning. Use Smart Path Planning to set a route with one tap. The ROV will automatically follow a zigzag-shaped path for high-precision autonomous cruising. Open the toolbox at the bottom right and set Default Depth equals 0.16 meters. Choose Zigzag Shape Route Planning. Select Left to Right. Set Spacing equals 4 meters. Tap Confirm. Draw a rectangular inspection area on the map. The system automatically generates a left-to-right zigzag-shaped route within the rectangle. Tap the Edit Layer icon to enter route editing. Long press and drag the white circular waypoints to manually adjust the route to avoid underwater hazards or dive zones. Tap a waypoint to view its position and depth. Modify the waypoint depth, then tap Save to apply. Log recording. Set the ROV to a level attitude. Tap the logging icon to start logging. Tap the white waypoint at the start of the route and select Depth Hold. The ROV will automatically travel to the start point and then follow the planned route. After it reaches the final waypoint, the ROV stops autonomous cruising. Tap the logging icon again to stop logging. The system automatically generates a log file. Log Download. Use Log Download to export collected log files and save them locally. Tap the Settings button, top right. Logs to view all log documents. Files with the QYBT suffix can be used for modeling. Files without a suffix are raw data records. Select the desired file to download or delete. Tap Download to save the file to local storage. Manual noise data removal. After removing noise data, the log data becomes more realistic and reliable. Subsequent plots will be smoother, cleaner, and more faithful to the actual conditions. Open and chart the data. Use an office suite to open the log file with the QYBT suffix. Select the depth column. In the toolbar, go to Insert, Scatter, and choose Scatter with straight lines and markers. Choose Insert Preset Chart to generate the scatter chart with lines and markers. Resize the chart and freeze the sheet to row 15, so the chart stays pinned at the top. Filter and remove by numeric rule. Select the depth column and enable filter. Apply a number filter, less than or equal to. Because depth values are negative, use this to catch depths exceeding the site's maximum depth. Example, if the maximum depth at the job site does not exceed 20 meters, filter depth less than or equal to -20. Select all rows meeting less than or equal to -20 and delete them to complete this filter-based removal. Remove outliers based on the chart. Move the cursor to any anomalous point on the chart, isolated spikes. The tooltip shows the row index and depth. For example, 212 minus 2.43 means row 212. Depth equals minus 2.43 meters. Scroll the table to that row. Confirm it's anomalous by referencing the chart. Select the row and delete it. Repeat the chart-based removal until the curve becomes smooth. Save as another format and rename the file to complete manual noise removal. Third-party mapping software, Surfer. This tutorial uses the PC application Surfer as the example. Surfer is a professional plotting and spatial analysis tool widely used for data visualization in geology, hydrology, oceanography, and environmental fields. 3D model plotting. Surfer supports converting raster data into 3D surface plots to visualize terrain, seafloor morphology, and other geographic entities with intuitive, three-dimensional effects. Open Surfer. On a new blank canvas, Plot 1, click Grids, Grid Data, Browse, select the log file, and double-click to open it. Click Next to proceed to finish and complete the log import. Minimize the dialog to obtain the contour map. In Plot 1, in the left Map Contents, select the Contours layer. In the lower left Levels panel, find Filled Contours. Check Fill Contours to show layer colors. Choose a palette under Fill Colors and click the ellipsis button for more color settings. For example, Reverse flips the color order. Under Data, Min and Max, adjust the min or max values covered by the colors. The minimum value corresponds to the maximum water depth. The minimum is 0. Click OK to finish color settings for the contour map. In Plot 1, right-click the canvas content and choose 3D View to preview the 3D model. In the top 3D View toolbar, choose Export Image to save a PNG of the 3D model, or Export 3D to save a PDF or other 3D formats. Return to Plot 1. Right-click the canvas content. Under Add to Map, select Post. Choose the corresponding log file to import the route track. In Plot 1, Map Contents, select the Post layer. In the lower left Symbol panel, click the plus sign before Symbol Properties to expand options. Set Fill Color and Line Color. Adjust Fill Opacity and Line Opacity. And under Symbol Size, set the track thickness to complete the route track styling. In Plot 1, you can check or uncheck items in Map Contents to choose layer combinations. Right-click the canvas content and select 3D View to preview the 3D model. In the top 3D View toolbar, choose Export Image to output a PNG 3D model image, or Export 3D to output a PDF or other 3D formats. Return to Plot 1. Right-click the canvas content. Under Add to Map, select Grid Values. Choose the corresponding log file to import and display grid data. In Plot 1, Map Contents, select the Grid Values layer. In the lower left Symbols panel, Click the plus sign before Symbol Properties to expand options. Enter a value for Size to set the grid symbol size. Set Fill Color and Line Color. Adjust Fill Opacity and Line Opacity. In the General panel, input X frequency and Y frequency to set the grid data density along X and Y. This completes the grid data settings. In Plot 1, you can check or uncheck map contents to choose layer combinations. Right-click the canvas content and select 3D View to preview the 3D model. In the top 3D View toolbar, choose Export Image to save a PNG 3D model image, or Export 3D to save a PDF or other 3D formats. Preview Settings Reference. If you cannot complete the above settings on your own, you can use QYSEA's sample template, simple.srf, for a quick setup. This procedure works for some scenarios, but may not precisely fit all needs. Open Surfer, go to File, Open, select simple.srf, and open the preset template. In the newly created canvas, Simple, select a layer in the map contents on the left, for example, Post. Right-click it and choose Copy, Properties to copy the style. Return to Plot 1. Select the corresponding layer in map contents, for example, Post. Right-click it and choose Paste Properties to paste the style. The quick setup is complete. Satellite Map Import. Surfer supports importing high-resolution satellite imagery from online map services as a base map to enhance visual context. In any plot, open the Grids toolbar at the top and click Grids from Server to access satellite map sources. In Select Data Source, right-click anywhere and choose Add New Category to create a new category, then rename it. Right-click the new category and select Add Map Source. In the dialog, enter Name, paste the URL, choose Type, and click Validate. After validation succeeds, click OK to finish importing the satellite map. Add satellite map layer. Adding a satellite base map on top of an existing terrain or contour map enables layer overlay analysis and lets you adjust display parameters such as opacity and map resolution. In Plot 1, right-click the canvas content, Add to Map, Base from Server, to open the satellite map picker. Select the satellite source you imported earlier. In Within, enter the map extent and latitude or longitude. You can also box select a custom extent. Click OK to add the satellite layer. In Plot 1, Map Contents, select Map. In the lower settings panel, open Coordinate System. Click Change. Search for World Geodetic System 1984. Right-click the result and Add to Favorites. Select it, then click OK to apply. In Plot 1, Map Contents, check the layers you want visible. On the top Map Tools toolbar, choose Digitize and trace the map edge. When the dialog appears, press Alt plus A to select all coordinates. Then go to File, Save As. Choose .bln, rename, and save to store the edge coordinates. Re-import the log data with the boundary. Go to Grids, Grid Data, Browse. Select the log and double-click to open. Click Next until Grid Data, Kriging, Output. In No Data Polygon Boundary, import the saved boundary BLN file and choose No Data Outside, then confirm. This imports the contour map constrained to the boundary. In Plot 1, Map Contents, select the Contours layer. In the lower left Levels panel, find Filled Contours. Check Fill Contours to show colors. Choose a palette under Fill Colors. Click the ellipsis for more options. For example, reverse to invert colors. Under Data, adjust Min and Max to set the color range. Min corresponds to maximum water depth. Minimum is 0. Click OK to finish contour color settings. Same import and styling approach as in 3D model plotting. Reservoir capacity calculation. Use the volume function to automatically compute reservoir capacity from DEM or depth data. Set a reference plane and obtain the stored water volume quickly. Open Surfer, File, Open. Select the preset template, simple.sre. Return to Plot 1, a new blank canvas. Go to Grids, Grid Data, Browse. Select the log file and double-click to open it. Set the X or Y data sources. Under X, choose column D, X. Under Y, choose column E, Y. Units default to meters. Click Next until finished to complete the log import, then minimize the dialog. On the Grids toolbar, click Volume to open the volume settings. Upper surface equals constant. Enter Z equals 0. Lower surface equals grid file. Browse and select the imported log grid file. Click OK to import and compute. The calculation results will be generated. This concludes the instructional video for QYSEA's QYBT Bathymetric Tool. Thank you for watching.